and there is another department which is separated for economics. I like to ask me the department, and I said, yes, we will be interested. It means after lunch, our president, practical skills are important. Yeah, myself, lunch here. Later, we will change to another department, which is 10 minutes from me. I would like to introduce to you.
So, ich bin bald durch. Hallo? Entschuldigung, dass ich da
Every year, the last 2 years, this is a special project Mr. Manoon and me have developed in Aachen. Very successful. We started 2015 last year, and we've been very, very successful. Yeah, until today, I get a lot of mails. So it is really a wonderful program, and especially Mr. Gertz is supporting us in the student program. She did an internship here. Big opportunity, big chance, visiting entrepreneurs in Thailand. One of them was a student from Mr. Manoon, and now he is running one of a really high sophisticated company, private company in tool making. Great. Friend, Professor Dr. Hoffmann, he was the last dean.
Yes.
Yeah, just a few minutes ago you could see his successor. Yeah, just to welcome and to say hello to him. Is it you are the head of this lab? Yeah.
No, not of this lab, but lab here. But I can show you around.
Okay, you give us a short idea before we leave.
I'll show you two labs, or let's say 3 rooms. This one is the lab of electrical drives and electrical systems for the students for demonstrations. For instance, you see here some of these racks. These racks are conventional PLC control systems. And with this, we have several tasks to realize some specific control tasks on this. Yeah? And partly we see it here, some connections via internet or via WLAN in order to give orders and to do the visualization on cabinet computers and so on. Yeah? Locally based propagation of a wave in an electrical machine. Yeah? It's just a demo for the students to make them better understand how electrical waves along electrical drives. See here are on this side works that are places where the students work on the thesis, be it the bachelor thesis or the master thesis, and he's working on this. Just show it. Yeah? It's something of three-joint leg of a spider, and his task is to work this out in order to set up a kind of automatic spider in order to control this system. Yeah? This is one of the tasks that he does. Yeah? And he's just finished his thesis at the moment, yeah, so he's in this final stage now at the moment. Yeah?
This is a very individual, practical related work in a closely relation between the student and the professors, you see. And you can imagine that if these guys are going out either with a bachelor or with a master degree, from the first minute they will be prepared to fulfill the requirements of industry. Because Professor Hoffmann and his team, that's what I know, they all are closely related with the industry, and they know what industry needs. And this is what we do in Germany, what we have to do. This is our, let me say, strength, and this is what Thailand needs so much. So, and therefore we are happy that we could cooperate in this part together with all of you.
Another object, for instance, is something that we also build ourselves, or this is set up by students. This is something of a generator drive systems, yeah, where you have a load. Yeah, this one is the load, and this can be as a servo load, for instance, applied in a different way. May it be a wind turbine, or may it be a rotor blade of a wind turbine. May this be the generator, or vice versa. Yeah? So you can just have a generator and you have a drive on the other side, and you measure how they work together. For instance, this then is something where you can measure the torques. Yeah? So this is something that we work on, yeah? And the students have to set it up and try to verify things like this. Yeah? It's usually done in a kind of thesis work. Yeah? Okay. Yeah? So now we just go through this door over there, and I show you something else. It's this is either the generator, and this is the drive, the motor, yeah. And we apply different sets of drives and different applications of load, yeah. Can be also something else. It need not be a generator, but can be something else. This is kind of servo drive, and we just make some applications on this. Yeah. Yeah?
Okay. Who wants to sit? Who wants to sit?
One of the girls can sit. Ladies first. So okay.
Nur Automatik, also only the
accelerator. So
An accelerator. Yeah.
And what we are usually demonstrating here is we are giving the course of a race course, and this system is a dynamic system which can move up and down. But fortunately, we are not going to have this moving today, yeah, because this would be something. So don't be afraid of it, yeah. It's just that you can just see how you can go through the racetrack, yeah. So now you can touch the
Lenkrad and
usually the brakes and everything else. And now you can drive onto the path.
Carefully. Wow.
Just go ahead.
Turn right. Carefully. Wow.
Process simulation on one side, and on the other hand, we have not applied the movement position because this is too dangerous.
normally and then now to first and
Now you go ahead.
only brake and gas. Yes.
Okay.
So this is the racetrack over there. Go ahead, the other way around. Just go ahead. And turn left.
Turn left.
Over the green. Left side.
Turn around. U-turn. Side.
It's kind of U-turn. Oh yeah, now you go.
Okay.
เอาเลยโทนี่ชูมังเคอร์มาแล้ว
Yeah.
เสร็จยาทำไมอ่ะ
มาแล้วเหรอ
ต่อแล้ว Willst du? Wenn die Pfeile gelb sind, kann man weiter rot als bremsen und grün nach vorne. Jetzt, ja, die sind Geschwindigkeit.
Up, cooling down, yeah. We are doing setups like the visualization, the control, the measurement, and the actuation of these processes, and they go on to develop these processes further. Level measurement systems over here, distance level measurement systems, and to find out what is the best for what range of level. An heat exchanger on one side, and the other one is a heat exchanger on the basis of these Peltier elements. Peltier elements for cooling down to the environment. We are developing PLC programs. These PLC programs are tested, developed for a given. You make a model of your plant, or of your system. In this case, it's a mechanical system or a pneumatic system, and you make a model of it. And with this model, you develop the control system, and this control system is then applied to the model. And if you find out that it works properly, only then you go ahead and switch it over to the real process, because this is something that we try to work out at the moment, because industry is asking for this, because the generation of PLC programs, pressure and all this missing time that you need to make the startup of a process is very short. So it's very good if you can do it on a model in the beginning. Then you have it tested, and the testing phase is only necessary for the remaining difficulties. These different PLC sets. We are working with the Beckhoff PLCs mainly, or with Siemens PLCs, but this is the favorite ones. You see also here we have these racks with different setups. Or in this case with the same setups. And the students are working on these PLC systems.
It is not a student to learn about this by job trip or design by self.
This is a mandatory lab that they have to do, yeah, and they are given an introduction. Yeah, they have a kind of leaflet which describes them how to set up, how to work with these systems. Yeah, so they are given an introduction. So let's say they have about 4 hours lab time. Yeah. So the first hour is just to get acquainted with the systems. Yeah. So they take out their booklet and look how to work with these programs. Yeah. After they know how to work with these programs, they are going to fulfill first tasks. Yeah. When these tasks have been done, they go ahead and do the just training tasks, and then they do the real programming of the given task. They simulate it here, and after they have simulated it, they go over there in the final stage and test it. So this one real plant is only used for this side here, and this one over there is for this side here. Yeah? So this is what they do then. Yeah? Okay, yeah. So there's one thing still that I wanted to show you. This is over here. We're building it, yeah. And this is a system where we do some, at the moment with another thesis, where we do some workflow, pick and place systems, yeah, with parts, yeah, and they are built together, and then they are transported in and out via a belt, a conveyor belt. Yeah. You see a similar system. This one here. This one here. You see here. This is kind of a two-dimensional parallel kinematic, yeah, and then linear drive, yeah? And you put in here some parts, and they go in here, yeah? And with the camera you see what kind of parts are given, introduced here. Then this camera detects what kind of part this is, gives an order to this kinematic system. This follows the part, picks it up, and so yeah, it just does some sorting in and so on. Yeah, so yeah, if it has a hole or if it's filled or if it's a small one or so on. Yeah, defect detection starting with this is self-built. Yeah, this is not bought; it's self-built. The construction and the realization of these kind of things. Yeah, this is by carbon fibers material in order to keep it light. Yeah. Yeah. And this is one of the applications that we have. And this one over here, if you look at this one, or something like this, and you put a ball on it, yeah. This is a ball, it's a metal ball, yeah. And due to the imprints, due to the touch panel facilities of this screen, you know where the ball is, yeah, and you do some control in order to follow the right track. Yeah, yeah, yeah. Okay, yeah. This is shutter screen in here being done by laser systems. Yeah, and these laser systems, there's a laser beam going in over these mirrors. Yeah, and he's just working on tasks where we have some assembly systems now. This robot has to pick up certain parts, like the ones that are shown there, and können Sie das laufen lassen im Moment, oder? Okay, yeah.
And again, he is working on his thesis. He's working on his thesis.
So he's just going to show you what he does, yeah? Ja, ist okay. Ich fange gerade mal kurz durch, ja? So, you know, it picks up one of these things there, yeah? Then it puts it over here. Yeah? Yeah. So like you see, everything is done in a safe way. Yeah? So if you touch it here, so it's not working. Okay.
Ladies and gentlemen, Professor Dr. Hoffmann, thank you so much for this presentation. Yeah, thank you so much. So,
have a nice day here in Aachen, and I wish you much success with my colleagues from the mechanics. Immer very effective. Genau, ja. Wir bleiben in Kontakt. Ja, okay, ja. Schön, ja. Okay. Oh ja, see, yeah.
The last one. The last.
Okay, yeah.
Okay. The last king.
Oh, okay.
Okay.
but Mr. Goertz will be with us.
Yeah, very, very nice.
View on what is the topic of this afternoon, railways. Okay, so I'm just giving a short introduction because later on then you can discuss with my colleagues which are responsible for train engineering here, railway engineering, or rail vehicle engineering, as they call it now. Always different names, also a question of translation. Okay, where are you here? FH Aachen, I think you have been to Alpenerstraße already. Have you learned about FH Aachen, or just a few words maybe? Okay. In the present organizational form, we exist since 1971, but had, of course, it didn't start at that time, but we had, of course, a number of previous organizations. So, for example, you see this building here is not a new building, but the large major part of the building is more than 100 years old, and it was always an engineering school. Okay, and different names of history, but it was always an engineering school, always mechanical engineering and electrical engineering. Okay, what is, you know probably about the different types of universities in Germany, that there are the technical research-oriented universities and what we call FH, or Universities of Applied Sciences, which try to more focus on the link to industry, link between practice and theory. So it doesn't mean that we don't teach theory, okay, our students also have to suffer. And they of course have to learn the maths and technical mechanics, physics and so on. But we always try to put an emphasis on why do they need it? Why do they need this mathematics? What can you do with it? How do you apply it? So there's much stronger focus on application than the more fundamental research-oriented technical universities like here our RWTH in Aachen. Okay, how large are we? By now we have about, well, it says here 12,000 students. I think we are now about more than 13,000 students by now. About 230, 240 professors, 800 employees, 700 to 800 employees. Well, we offer a large number of bachelor and master programs, mostly in engineering, but also business, design, architecture, and related subjects. Okay, but the strong emphasis, the strong focus is on engineering. We have a lot of international cooperation, so Thailand is one of them, but also with all parts of the world. We have joint projects, sometimes also dual degree programs, student exchanges. We are quite internationally oriented, that you already see from the fact that about 20% of our students are international students. That's for a German university, I think, a relatively large share. We don't find many universities with a larger international share. So it shows that we put an emphasis on international relationships, that we think that is important. We also always like to encourage our students to go outside, which is sometimes not easy. Okay, so now here this building, as I said, okay, this is a building showing it more than 100 years ago, founded in 1902, over different stages until we became Fachhochschule, or University of Applied Sciences, in 1971. Here we had always engineering. First it was electrical engineering, mechanical engineering together, then later on split into 3 departments that we have now. And mechanical engineering, since many parts of mechanical engineering cannot be separated from electrical engineering, we also now offer bachelor and master programs in what we call mechatronics, so synergy of electrical, mechanical, and information technology. This is, by the way, we offer together again with the electrical engineering department. Okay. But a large share of the responsibility for this mechatronics programs is from here. Okay, I think that should do for now. Now I give over the word to Raphael Pfaff, who will give you an introduction to what we do here in railway technology. We also have a bachelor program in railway technology. So it's a specialty of this department here, which you don't find very often in Germany. I think there are a few of these study programs specializing on the technology of railways. Okay. Thanks for the attention. I'd like to wish you a very successful visit. Enjoy your time here in Aachen, and I hope that we'll have a fruitful cooperation in the future. Many thanks. Because of another meeting, I'm sorry that I have to leave now. Okay.
Allow me to say some words. Professor Henning.
Kemper.
Kemper. Sorry, Kemper. Sorry. First of all, thank you very much for this warm welcome. I would like to ask something or to explain a little bit before, because we couldn't manage it on time. Our gentlemen, our guests, are from different institutes in Thailand under the umbrella of the ministry of so-called DOF, which is the Ministry for Vocational Education and Training, for vocational training in Thailand. We are very much interested, and this is what we have prepared a long time ago, with Professor Schmidt and with Mr. Gertz, that all these institutes will be very much interested in the future to come in touch or to cooperate with your institute, especially related to the railway technology. That's why we have prepared a declaration. I say it because I do not know if you have to sign it, if you could sign it. A declaration, this is important. This is a declaration of cooperation between University of Applied Sciences Aachen, Faculty of Railway Technology and Rail Vehicle Engineering. This is a translation. You see, we had to prepare it in a short time. So I would like to ask you, and I would like to please, that we could sign it. At the moment, it will be signed by Dr. Manoon, by the relevant head of this institution, and by me. You see, I couldn't introduce myself. I'm Franz Dunkel. I'm associate professor of the RWTH, but closely related with Fachhochschule since a couple of years. I will sign. Then I will ask you now, before you leave, who could sign it from your side, and then later
one of my colleagues could sign.
Okay, then it's fine. Then it's fine. Then you give me the credit card, not the credit card, the name card, and then the business card, and then we will add your title later, because we couldn't be sure who will sign it.
Yeah.
Yeah. Then this is clear. Sorry, interruption, and to say thank you very much to you again. And
we have some gift for him.
Well, give this gift to the people that will really take care of you. Two.
No, they have a lot of gifts.
They have a lot of gifts.
Das müssen Sie jetzt übersichern.
Okay.
Das gehört zur thailändischen
Souvenir is my team is the king of Thailand.
Okay.
Yes.
Our king.
Okay.
Okay. Thank you very much.
Thank you very much. Okay. Okay. So a successful visit.
Okay, thank you.
Okay. This was an interruption indeed. Within Aachen University of Applied Sciences in 2010, there was a group formed long before I was here, unfortunately or fortunately, I don't know, which was formalized because in Germany there are so very little undergraduate courses in rail vehicle engineering. And as in many other countries, we experience a true skill shortage in our railway sector, having many people from other industries entering and having to be trained specifically in the railway sector. So this is why we called, same as UK currently does, they built an own college to educate railway engineers. We formed this course of study as an undergraduate bachelor's degree in 2010. We have a true rail vehicle engineering undergraduate, which means that they have only 1.5 years of mechanical engineering general training and then 2 years of specialization for the rail vehicle industry. This means we can go through a lot of details in mechanical subsystems, wheel-rail interaction, and we cover a lot of material that is at Aachen University covered typically in the masters, on the master's level. So in the mechanical subsystem, which is my piece of the course of study, we focused on brakes and couplers because I was with February Transport before, working on brakes and couplers. Electrical subsystems, which is Bernd's portion of our course of study, we focused a lot on the general traction system, including diesel and hybrid engines, so current technologies and future technologies. The energy supply also plays a vital role depending on what your infrastructure is and the control. And what's also interesting is that our students, they know the whole system approach. So they can truly drive, at least in a simulator, a rail vehicle. They know how their systems they design interact with the general railway system. So this is why we have a third professorship on railway systems engineering, who focuses on the interlocking system, simulations, which is a quite interesting portfolio, and actually we don't see this in Germany a second time. So I told you we are three of us. This is the three of us in the back, and in the front is our Ministry of, how would you translate it? Infrastructure and Transport of North Rhine-Westphalia, so the federal state we are in. On InnoTrans in 2014. The first one to join the course study was Manfred Enning, to the right. He is a railway systems engineering professor, formerly with Aachen University, Institute of Control Engineering. You will see that control engineering is a common background for us. He has an extensive experience with freight, and he's the father of what we call the Freight Wagon 4.0, so a current IoT connected freight wagon. He also worked in adhesion control system, being a control engineer, and now he works a lot of trade protection system networks and also traffic estimation, which may be of interest. Not bad. I tried to introduce you as briefly as possible. Bernd teaches the railway drive system, but also general electrical drive systems for the mechanical engineering course of study. He was with a large consulting firm. I don't know if we're free to tell it. It was McKinsey, consulting railway companies around the world. So he's a really, for me at least, a really important source of information on the interface between railway undertaking, vehicle supplier and system supplier. So quite interesting source, which reflects his experience. So he did his PhD in transport science, being an electrical engineer, worked in consulting, and of course consulting, then you go with a whole life cost approach to your customers, optimize a lot. He's really knowledgeable about all safety and reliability issues from 1900 to today. I'm really, always surprised, really. And what is interesting, because he had a very good insight into bid processes, being a consultant. So this is quite interesting. So the last one to the center, that's me. I work in the rail vehicle engineering, also teach pneumatics and quality management for our general courses of study. I was with February Transport. It's I don't know if you're aware of February Transport. It's now a Wabtec subsidiary. So one of the major brake suppliers in the world. Being a system engineer for brake system, and I was also manager of the couplers engineering department, which explains my experience partly. Before I joined February, I was with Siemens in the drives sector, but as a system engineer, so coming from very abstract perspective. I worked on braking systems, buff and draft gears, generally system engineering in terms of requirements engineering and how to properly do a requirement specification, reply to it. Of course, I did product engineering and mechanical design, a lot of reliability engineering, mostly, unfortunately, being a system supplier, you want to sell your stuff and never hear of it again, but sometimes you don't. Claim management was also one of these items. And sales and marketing, because system engineering and field transport is also sales engineering. And this is interesting insight because it brings you in contact with your customers and this tells you about the cost structures. This is also what Bernd profitates from. Du sagst halt, as you like.
Yeah, we can change.
Yeah.
Thanks for the nice introduction. What we do here is not only research, but it's also teaching. So we have a bachelor course concerning rail vehicle engineering, and in this course we have different topics. One thing is rail vehicle engineering itself, the mechanical system, brakes, couplers, and everything you need there. Then the next thing is the drive system. We have the electrical drive, we have diesel and hybrid drives. Then what my colleague Henning does is signaling and interlockings, control and simulation techniques. Then what we do together, especially rougher, that's manufacturing and marketing. Then we have the drives technology, electrical drives, pneumatics, statistical methods, methods of quality and management. That are the things we do for our bachelor students. And what's our special focus? We always have a close contact to the practice in work. So we have a close relationship to railway companies here in the next environment of Aachen and also Aachen itself. So what we always do every semester, we have our students to meet at, for example, a railway workshop and go into details, what are the problems they are facing there, so what they also see, how is maintenance being done in reality. So we have a cooperation to German railway. You see the German railway depot out of the window. So we are normally once a year, we are there with our students and are looking what are the issues they face there with some wagons. Also some of our students have been working there before they started their bachelor degree. We also have a workshop in Düren, that is of a small railway company, it's called Ruhrtalbahn. They have diesel electrical multiple units, so we also know what is being done there in the maintenance. But not only teaching, we also have research and development. So for example, my colleague Henning did a big research project about powered trade wagons. Then I myself, I'm just a refurbishment project for electrical locos. So we are optimizing the whole power control chain in an electric loco. Then my colleague Faf is an estimation of reliability characteristics from existing data. You see this little graphic here, so you can use mathematical methods and the big data approach in order to have a good estimate when parts will fail in the rail vehicle. And for sure we also have a usage of additive manufacturing, especially for spare parts. And after that little presentation, we prepared a visit of some labs. So you will see our labs for rail systems engineering and our lab for additive manufacturing. Another thing which is always also part of our work is consulting. So we do technology roadmap, mapping, strategy development, operational cost optimization, and many more things. That depends who asks for which kind of work. For especially, I did some project for some rail operators. They had issues with the maintenance because some problems were recurrently there, and so we were looking what is the problem with formation of the maintenance people. What do they need in order to fix a problem forever and not fix it for a week, and when the problem is back again and they start fixing it and they never stop fixing it. So that are things we do. And what our vision for the next years, we will get a new building. It's over there. Perhaps you saw the construction site there. And in this building we will have not only CAP simulation but also a 0.7 megawatts electric motor test rig for traction motors, also train braking system, door systems, and systems where you can task network communication together with the hardware in the loop, and also for sure further subsystems. What we also have is a laboratory currently at Talbot manufacturing yards. Perhaps to see it together with Street Scooter. We have a laboratory there where we have our own tracks where we can disassemble, for example, rail vehicles. And we also have a picture here that is in these labs where we disassembled local buji and removed the traction motors and the wheel sets. So that are also things we can do here, not every day, but with some notice in advance, we also do things like that. So, why are we sitting here? I think it's because we want to share knowledge, we want to do perhaps some seminars together, and we have some kind of seminars we already have in the drawer, but unfortunately, mostly still in German. So for sure, also the first step when we do it together, we have to translate some things, and especially some safety concepts are different in Germany than in Great Britain or other parts of the world. So these things need to be for sure a little bit adapted. If you look into signaling systems or what your requirements on brakes, that depends on the signaling system, that's different. So if we do something like that, we have to adapt it. What do we have here? We have courses about the whole mechanical subsystem. We have courses concerning the electrical, hydraulical, and combustion systems, railway control engineering, railway civil infrastructure. That's something we do not do here, but that does our colleague Joachim do. It's a different building, and unfortunately he had another meeting today, so he's not here in our meeting. And for sure, maintenance and lifecycle costs. Seminars, in our perspective, include always multiple things. We start with kind of classroom lectures. We do some classroom exercises where you have some little problems which are posed and you say, okay, you have to calculate something, you get a solution. And for sure, laboratory or factory or depot exercises or visits. That's really things you work with a train, you work with vehicles. That's normally not done in this building, that's done at our partners in the industry. And for sure other things as project-oriented work. And what we also have for each seminar, they are always learning progress visits. So we will check if what we teach will also be there. And that depends how it's then done in detail. We did a seminar on electrical safety some years ago, and there also did some quizzes, and then for sure the people get also a certificate of attendance, and that also shows the result of the quiz. Normally a percentage number or something like that. That's how seminars here work, and we offer seminars to external partners. And I have also lots of what's included in these seminars, what's the topics. But I think we won't need to discuss this in detail. I'm not sure if you're really interested in what kind of cable is where. So you see there's lots of things we already have. What's still missing is things which are specific to the country. So that's specific for Germany and for some European railway companies. But for example, I don't really know each detail what you have as a metro system in Bangkok or somewhere else. What are your special requirements there, and what you have to look there concerning safety. Yeah, thanks a lot for your attendance, thanks a lot for your interest. For sure you can also contact me, and I can also give you that kind of presentation. I will give it to Mr. Dunkel, and he will send it around by email so you can directly print it out. You don't need to make the effort to take photos of it. Okay? Yeah, thanks for that. The next thing, what is prepared is the laboratory visit, but I think...
Yeah, before we go, allow me a few words. Professor Pfaff, Professor Wirtz, thanks so much for this presentation. I would like to underline something, ladies and gentlemen. I think this is a very, very big chance we have. You see, this university is very open for international projects. This is not a norm in Germany. Many research institutes are really focused on research, and they are not open for tailor-made cooperations. So therefore, let's use this chance. You see, I know. You see, I told you that Thailand for me is like a second home, and I know the country very well because of the close relation to Dr. Manu too, and we know about the main important subjects at the moment. And I think it's also important for our German colleagues. It's railway technology. There are a lot of developments in the future. It is agricultural technology, which we will visit tomorrow. It is aviation and avionic. We start a program end of this month in Maastricht with the Aachen-Maastricht Airport and the ACC Aviation Competence Center. And it is mechatronic, precision machining, which is based on the so-called Time Meister program, which we have started last Monday. At the moment, we have 18 professors and doctors from Rajamangala University of Technology, Danchaburi, in Aachen for 10 weeks, and this is great. And we are very hopeful that in the future we get more partners and more friends and colleagues from other universities, from ISAN, and we are very happy today and proud to have you here, because our colleagues today are representing the ministry, the government. It's right, yeah?
Right.
So, and this is important. The government is like an umbrella, you see. And we have to convince the government. And if I look into your eyes, I'm sure you are convinced already, because we all are well experienced teachers and experts, and we know that a practical practical skills and knowledge will be very, very important. And that's also what we can find here. What we can find here under the roof of this university. Therefore, we are here, and I'm very thankful, Professor Schmidt, Mr. Goertz, who is a bridge builder and a good partner in this project, Professor Pfaff. And I would like to take this opportunity also to introduce another professor, Professor Wolf. Yeah, you see, he is. I invited him to be here tomorrow, although he is not involved in any project at the moment, but he knows Thailand very well too. He is very much interested. He is representing a very important subject, which is IT and management. Information technology, I think, is a subject which goes through all other subjects. And thank you for coming. And we are very hopeful that we could also build a cooperation, and any time to sign a cooperation contract with him. Thanks also for this opportunity.
We will inform the Thai workshop in Beijing,
Yeah.
and German workshop in Thailand too.
Yeah, they are closely related. Especially Dr. Manun is also a member of parliament in Thailand, and he is responsible for the development of the vocational training in the country. And on the other side, closely related to both embassies. Today, you will be visit the embassy this time too?
No.
No. Okay,
But
you
we inform them.
Yeah, and there is another nice thing. I welcome our cameraman. Allow me to say he's from the Thai television. Yeah, really, he's from the Thai television in Thailand, and we are preparing a marketing strategy. Thanks, my friend Dr. Manu, that he made it possible. I think nowadays, in a world as we live, global oriented and so on, what we see, we understand, you see, and if we can anytime bring this picture into the television, I think it will benefit all of us.
Yes.
Last but not least, the country, the wonderful people in Thailand, the young people in Thailand, yeah, who have to build a future based on a new kind of qualification. Thanks a lot. And I think the highlight is coming now when we will visit the labs. The lab, again, there is no institute, there is no professor without a lab. This is the relation to the industry.
Yes.
This is it. Thanks so much again. Sorry for this long talk. Dr. Fach auch?
Ja, rein.
Kommen Sie gerade? Jawohl.
Ja,
Allow me to say something, Professor Schmidt, Professor Wolf and Professor Bach, about this matter, concerning these matters. I'm proud because I got some. And nowadays, today, these medals are of a very special understanding because the king died last year. I was in Bangkok 3 days later. And I knew Princess Silicon. Yeah, she came in, I shake her hands. She was in Aachen here, I know her. And he came to the RWGH. And therefore, this medal, I heard in Thailand that they told me, oh, if you have it, you become a rich man. Because any time in the future, you see, because unfortunately he passed away. But you know, many people become in Germany very important after they have passed away. I hope it will not happen with us. No, only a short explanation. Therefore, it's a really special gift. Not so many people get it. I know that. Thanks. So now I would like, Professor Schmidt, if you, entschuldigen Sie, wenn ich das jetzt so mache, ich sage mal, das ist einfach eine Zeremonie, die notwendig ist. Later we will take his name, his titles. Yeah, okay.
ไม่เสร็จนะ
มีทุกคน
ไม่ใช่เอาแฟ้มมาไม่เอาไม่ใส่
เดี๋ยวใส่แฟ้ม
ไม่ดูดีนะโอเค
ไปไปดูเลยครับใครจะก่อนใครจะต่อท่านเอาเลยหรอโอเค
ขอบคุณนะครับ
ต่อไปครับเข้าสู่การไฟกับพินไปสถาบันหนึ่งครับ โอเคครับต่อไปครับตายครับพักดีครับชั้นตอนนี้
Thank you for everything. And I think you have some implement after this.
Okay ครับต่อไปครับ
level of control. But for myself, I can do something more. But if you think about the place to increase about this, maybe copy some place, possibly because we think about the rules of the railway, the rules of the line like that. So this is maybe after about
ต่อไปครับท่านสมพงษ์ครับท่านสมพงษ์
the start with the basic sensor. And for this one, I think for the drive, laboratory, for the first time, not in the college, but only in the state railway that only teach in the train, in the college, and previously, which is one.
Last one. So last one.
For the speed trailer and I think also because
That's it.
So what this laboratory features is a rail vehicle driving simulator. Maybe you should try yourself. Then we have a simulator for an autonomous freight vehicle concept. Maybe we will show later.
It's offline today.
It's offline today, so we don't show. And of course, interlocking system simulator with 2 workstations, so you can pass the train. It's not that difficult. Even I can do it. As long as Tim is.
They have a, so then the next is the big panel in the middle. Yeah, it's the deadman security system. You have to press it, and every 30 seconds you have to lose it and press again, so that the engine is knowing that you are still alive and driving. And then you can see the air pressure level.
Yeah, something like, but also he can introduce, for example, the or something, so he can introduce some training simulator. This is stress. Okay. So I guess you should also. There's the board.
We have to wait a little bit, maybe we just
so they
maybe now we have to stop there. There's a red signal. Okay, yeah.
We do
So now it's by 5 bar. Okay, wait. Now you can start with traction. We have to wait for the pressure again. Yeah.
in my lectures here.
Now we can go
And
there.
I have like 1,400 people on something.
Kilometers per hour.
So this is,
Again, we have to wait for the 30 kilometers.
30 kilometers only over there.
Yeah, only 30.
Which is quite a strong road here.
Please brake a little bit.
And because this is freely published and mostly standard to all current locomotives and even high-speed trains, and ICE driver's test doesn't look that different. Especially the position of all control elements and the manipulators is standardized, so the driver in the dark can feel what he's using, what he's doing. So this is one of the important safety aspects in German homologation. Everything is possible in smoke, in dark, during fire, during extreme stress situation. Everything has to be. So how is an emergency brake done? Normally that it's the most intuitive way. You know, if you're scared of something, you just push the lever, you pull the lever towards you, and then you have
Emergency braking from 120 kilometers per hour.
Should be like 600 meters.
Wow, how many seconds?
Yeah. So, and this product is now a commercial product, but I think we were pilot customers and development partners and still are development partners. So there's many. Tim is spending a lot of time always playing beta releases and testing them. So this makes him a good driver already. This is something that, of course, your students, if you send them here, would use. It is not sensible to train them for hours on the simulator, but it is very important to give them the feel. For example, now you did this emergency brake, and it takes you 600 meters to come to a standstill. Now this is an important takeaway you take into engineering of your signal system, of your brake system. It's an important and very practical takeaway. So this is why we have the simulator. To see how the tracks are laid, how the Fahrstraßen, the movement authorities are shaped. And also this is quite an important takeaway for them, and indeed we have quite a lot of students working on interfacial topics. I have one graduate now working on investigating into a rail accident where we had a crossing during shunting operation. So no fatalities, nothing happened truly, but of course they want to know how can we avoid this in the future. And this is now a topic between infrastructure and what happens on the vehicle, so braking system. If you think of, you know, you have a nominal braking performance, you see in the simulator, but then it may be wet, it may be autumn with leaves and stuff, and you have twice the braking distance. How do you reflect this knowledge in your interlocking system? So this is very practical and leads to many takeaways. And how we do this in the other branches, like brakes, for example, we have a small locomotive currently built, 1:5 scale, with a new pneumatic brake, with a true traction system, so we can play around without hurting ourselves. It's just 500 kilo instead of 90 tons, so it's not a true toy, but it's something that invites you to play. Yeah, it's about having fun, I guess. Okay. So if you have any questions, feel free to ask them.
Control system like that, or how to drive the locomotive like that. I think we just start, and after we go back, we have to think what the point we want to train.
It depends on where they're put into service later, but it's always, this is probably the German approach, it's always a good idea to give a guy who's in a control room also some aspects of driving and other way around.
คือที่ระบบเลยจะเป็นอย่างที่ว่าเรานี่เขาพูดเรื่องระบบเราปัญหาเราจะทำระบบแค่ไหนเราที่เราจะทำเราดูสิ่งที่เราต้องการคือการที่จะเตรียมคนในเรื่องของไปทางอื่นมากกว่านี่คือการวางระบบนะเหมือนของตรงนู้นเนี่ยนั่นคือการขับ
เดี๋ยวเราต้องคุย
ต้องไปคุยต้องไปนั่นเรื่องว่าเราต้องทำ sorry try to assess its impact.
ไม่แล้วคอร์สแบบเรียนนานแค่ไหนปีหนึ่ง
ไม่มันว่าที่สุดนะ how long the training course in about this how long about
typically these two lab sessions are part of round about it's 5 hours lecture, so it's 14 weeks, so like 70-80 hours. So this is what Bernd I think put into is one of the 80 hours modules. So it's 2 weeks. It could be reduced a bit, but it's not sensible to reduce it too far. And it's not only wie viel Praktika macht ihr?
6.
There's 6 lab sessions of each like at least 2 hours.
Yeah. 2 on the simulator and 2 on this. And for this we have 3 on the mechanical.
We have the mechanical interlock system to understand this one also. So it's very, and then also there's typically a report to all practical lab sessions, so helping you reflect. The laser beam will be put inside in the machine, and in this area we have the optics of the laser, and in the bottom we have the building chamber. It will be filled with net gas. The other chamber at first you have to put there some support structures to cut it later from the platform. You see it here. And set the parameters for the process. And after that, you slice the 3D model. That means you cut the digital model in different layers, in a defined layer thickness. And after the recording, so you can put on the platform different parts, and it starts again. So you can build it layer by layer. I will do it a little bit faster here. And here you can also put 2 different fluids inside for this sample for a tool. Like if you do it in a CNC machine. Yeah, it's my pleasure. Have a nice day.
You have which are necessary for railway traction. So we have then a real locomotive in the laboratory, as we said on the slides. We will especially look into control algorithms there and also efficiency. 6 metric tons. 60 kilometers per hour. And can pull a normal passenger train. You have a high-speed train with concentrated traction, the motors are similar to this. If you have distributed traction, the motors are smaller, but they are less efficient. So normally concentrated traction is always more efficient than distributed traction, high-speed trains. I also worked in the maintenance of high-speed trains, and you can also simulate a high-speed train with this kind of motor, but you have to change the ratio of gears. Because for a high-speed train, you need a less gear factor, which is smaller. So we call heavy iron ore, and you have a low gear factor for high-speed trains. So that is all the difference. So you only shake the train, you have less.
Yeah, ladies and gentlemen, I think we came together here to say some final words. First of all, I have to thank our colleagues. I'm sure you don't want to interrupt you, Professor Pfaff and the other, our Professor Schmidt, of course. Professor Schmidt and Mr. Goertz. We started a discussion about any kind of cooperation. I really appreciate it also to tell you, and you should know it, that these two gentlemen, he built the way, he found with Professor Schmidt, and he told me possible that he will be interested to cooperate. And then we started step by step. And now, really, myself, I have a good feeling today, this morning, yeah, that we all enjoyed this coming together, this meeting, and signing the MOU and looking into the future. We are prepared to fulfill any requests from your side. We are ready to start with activities. Professor Schmidt mentioned it, either in training programs in Germany, short-term courses. The courses are ready, and long-term, coming to Thailand, to doing courses in Thailand, whatever. Yeah? And you can't learn to know each other if you don't meet each other. We met today, and I think it's a good prerequisite for looking into the future. It's the first visit today we had here at the university. I hope for many, many more activities and cooperation in the future. Thanks a lot again. I will get the presentation from Professor Schmidt, the presentation we saw before. I will send it to Manoon. Manoon and me, we also are collecting all the data, for example, being important for anything in the future. What we want to do now, I think we have, you arrived this morning, 6 o'clock, by night flight in Frankfurt. I did it 3 weeks ago, I know. You came by bus to Aachen. Then you had this meeting. And I'm very sure you are strong, you have to be strong, because normally people become tired, but you should not become tired. But we will stop the official program now, and we will go downtown. That you can do whatever you like in the city. You will see the city is wonderful, yeah. And from there in the city, I think we will meet in a restaurant. Okay. It's from downtown to the restaurant is only 5 minutes. By walk? By walk. Those who do not like to walk, they can stay with me or with Mr. Korte. But our plan is we go downtown now, find a parking, and then you are free. You could leave your luggage into my car, because if you don't like it, to take it with you around. Yeah? Okay, are there any questions, either from our sides, from the German sides, or from your side? I think it's a good opportunity now before we say goodbye. We don't say goodbye, I don't like that, goodbye. In Germany, these are some German words I would like to teach you. Auf Wiedersehen. Auf Wiedersehen. That means see you again. I like that more than goodbye. Goodbye means, oh, never see you. But we want to see us again. Don't forget, auf Wiedersehen.
Auf Wiedersehen. Auf Wiedersehen. Auf Wiedersehen.
Any questions?
On behalf of our program, thank you to everybody.
Thank you so much.
I think for today we got to sign ceremony, and then I think implementation, something going on.
Exactly.
And I hope I will come again.
Yeah. I'm really very happy to have colleagues like you, because with these experiences, there are so many energy we lose speaking, writing, but nothing happens. Doing, yeah, yeah. As the last president said it from America, the better one. Let's do it. Make make some mistakes, not a problem. Learning by trial and error. This is a very intensive kind of learning. Let's do it, don't waste time. Yeah. How is it called?
Yes. Skytrain.
Skytrain, for example. Yeah. And the underground. Oh, great. You see, this underground. And Skytrain. Train is really a vehicle or a kind for moving and for the people, for example. Especially in cities like Bangkok with nearly 6, 7, 8 million. This is great.